Newton's law of motion. By the end of this topic, you will be able to describe Newton's first law of motion. When an object changes its position, we call the change in position as motion. Sir Isaac Newton, a great scientist, developed 3 laws of motion and published them in 1687. Newton's 3 laws of motion apply to every movement in the universe and in all our daily life activities. To understand how this change works and which forces are needed to generate this type of change, let us understand Newton's 3 laws of motion. Newton's first law of motion. Newton's first law states that a body continues to be in its state of rest or in uniform motion in a straight line unless an external force acts on it. In other words, all bodies oppose any change in their state of rest or motion. This tendency of bodies is called inertia. Newton's first law of motion is also known as Galileo's law of inertia. There are 3 types of inertia: inertia of rest, inertia of motion, inertia of direction. Inertia of rest. When a bus suddenly starts moving forward, the passengers in the bus fall backward. This happens because the passenger's lower body part, being in contact with the floor of the bus, comes in motion along with the bus. On the other hand, the upper part of their body remains at rest. This tendency of the body to continue in a state of rest even when some external unbalanced force is applied on it is referred to as inertia of rest. Inertia of motion. A passenger falls forward while getting down from a moving bus. This is because as the foot of the passenger touches the ground, the lower part of his body comes to rest, while the upper part of the body remains in motion. This tendency of a body to oppose any change in its state of uniform motion is known as inertia of motion. Inertia of direction. A stone tied to a string is whirling in a horizontal circle. If the string breaks, the stone flies away tangentially. This is because the stone moving in a circular path has the direction of motion along the tangent at any point of the circle. As soon as the string breaks, the force acting on the string ceases and the stone continues to move along the tangent of the point of the circle. This tendency of a body to oppose any change in its direction of motion is known as inertia of direction. Inertia of mass. All the above examples illustrate that there is a resistance offered by an object to change its state of motion or rest. This property is termed as inertia of the body. As we know that any large or heavy object shows a greater resistance than a small or lighter object. Quantitatively, the inertia of the body is measured by its mass. The mass of an object is the mass of its inertia. Momentum. Newton introduced a new property called momentum P, which is defined as the product of its mass m and velocity v. Momentum is a property of a moving body by virtue of both mass and velocity. That is, momentum equals to mass into velocity, P equals to mv. Momentum is a vector quantity and the direction of momentum P is similar to the direction of velocity v. The SI unit of momentum is kilogram meter per second. Magnitude of momentum is equal to mass into speed. Summary. Let us summarize what we learned in this topic. Newton's first law states that a body continues in its state of rest or of uniform motion in a straight line unless an external force acts on it. The tendency of body to continue in the state of rest even when some external unbalanced force is applied on it is referred to as inertia of rest. The tendency of a body to oppose any change in its state of uniform motion is known as inertia of motion. The tendency of a body to oppose any change in its direction of motion is known as inertia of direction. Quantitatively, the inertia of the body is measured by its mass. The mass of an object is the mass of its inertia. Momentum is a property of moving body by virtue of both mass and velocity.